All right. Hello, everyone. Thank you so much for joining us today. My name is Marriott Haggerty Peralt. I'm the CWEEL chapter liaison for our New England Association of Energy Engineers chapter. Today, we're really excited to have you all join us to learn a little bit about life cycle assessments and the role that they play in the energy sector. We have today with us Andrea and Masa of UMass Lowell, University of Massachusetts Lowell, excuse me, and we'll get to them in just a second. So CWEEL, the Council on Women in Energy and Environmental Leadership, is a division of AEE that was formed back in 2007. It's a group of professional women and allies supporting underrepresented demographics in this historically male-dominated field. The mission is to support career development through mentorship, networking, and scholarships with technical and leadership training opportunities as well. We do have a governing council at the national level or corporate level, as this does involve international folks too. That helps steer the direction of the group within AEE. You might notice a few familiar faces from CWEEL New England that are also on the governing council. So Caitlin leads the mentorship committee. She's a local New Englander, and Hadass also leads the US membership committee. So this is another way that you're able to get involved too. On a more local note, CWEEL New England's advisory committee is led by Andrea, our fearless CWEEL lead and co-founder, actually. I happen to serve as the chapter liaison, as I had mentioned, and we get a lot of additional support from our steering committee members, such as Danielle Crocker and Nicole Voudrin, as you see here. We're always looking to grow this advisory group, so please do reach out if you are interested in getting involved. It's a pretty low lift, but lots of reward. So if you're interested in becoming a member, for those that are already AEE members, you can actually just add CWEEL to your membership for free. We'll look at that in the next slide. And if you're in the New England area, please feel free to reach out to us if you're looking to get involved. We do thankfully have a very well-established group here in New England, thanks to Hadass and Andrea. So we can provide support if you're in the area to get involved, but also can give you pointers if you're spread out across the country here and might not have a CWEEL group in your area. There's also the opportunity to always join the CWEEL Governing Council, regardless of where you are geographically. For those of you that are the AE members, when you go in to renew your membership, you can actually just upgrade your membership to have the CWEEL option. Oops, sorry, there was a little background noise there. So this is, again, for those folks that are already AE members, and for you folks that might be signing up for the first time at aecenter.org. When you join AE National or Corporate, you can also just add this upgrade for CWEEL. And again, upgrade's a little bit of a misnomer. There's no additional cost associated. So for folks looking for some context on the type of events that we host here in CWEEL New England, this is what 2024 has looked like for us. We typically try and do about 4 to 6 events a year. And in January is actually where we met today's speakers. We hosted an in-person elevator pitch workshop to refine how we introduce ourselves or projects we might work on. I found it very valuable. And in March, we hosted a book club on a book called Never Split the Difference, where we learned how high stakes hostage negotiation tactics can actually apply to navigating our careers. We're obviously thrilled to be hosting this life cycle assessment workshop today. And we'd like to have you save 2 dates coming up this later this year. So August 22nd, we're going to be doing a few happy hour get-togethers. In the late afternoon, decentralized. So we're going to do probably in the Boston area, the Providence area, and the Hartford area. And we'd love to see you all in person there. Then in September, we will be hosting our 3rd annual volunteer day on the 20th with a great nonprofit called Community Harvest Project. They grow fresh produce for local food banks and service providers tackling insecurity in central Massachusetts. So we hope you'll save August 22nd and September 20th for getting involved with us if at all possible. And again, if you're looking for a way to learn more, you can always email CWEEL at aeenewengland.org or check out our website, aeenewengland.org/CWEEL. And now onto the main event. So Andrea is a PhD student in mechanical engineering at the University of Massachusetts Lowell. She specializes in enhancing the resilience of energy systems within buildings with a keen focus on sustainability. She's gained valuable industry experience, particularly in power generation through prior consultancy work. Masa is currently pursuing her PhD in industrial engineering, also at the University of Massachusetts Lowell, and has a focus on developing advanced life cycle assessment tools for designing sustainable and resilient residential structures in the United States. Her work includes leading comprehensive LCAs for significant projects like the Lowell Geothermal Network and developing innovative LCA tools for energy efficient building design. Sorry, my screen was in the way there. And with that, I will stop sharing my screen and hand it over to today's two presenters. If you want to go ahead and share, that'd be great. Awesome. Thank you so much.
Thank you, Mariette. Thank you for the opportunity to be here today. Thank you, all of you, to be here. So we jump there. Yeah. So, well, a little bit of background. I am mechanical engineering from Ecuador, and I did a master's in energy conversion and management at University of Nottingham in the UK. And now I'm doing my PhD at UMass Lowell. Next, Masa.
Hello, everybody. Thanks, Marietta, for your introduction and introducing us. I just want to tell that welcome to today's webinar for on the vital role of LCA in paving way for low carbon solution and sustainable energy future. It doesn't matter whether you're familiar with LCA or new in this concept. This session is kind of provide insight into the why LCA is important, the history and the applications of LCA. My name is Mahsa Gandhi, and I did my bachelor in civil water engineering, and I did my master in water resources engineering. And during my master, I worked on water supply system sustainability, and I'm a PhD student at UMass Law. So by this, I'm gonna start with the definition of LCA. So generally, what is LCA? Life cycle assessment is a systematic method that used for evaluating the environmental impact of a product, process, or service through its entire life cycle. This includes all stages from raw material extraction to manufacturing, distribution, use, and end of life or disposal. So the aim of LCA, by considering all these stages, is that to help for identifying opportunities for reducing environmental footprints and improve sustainability. Let's see about the history LCA, where it is beginning. In 1960s, the concept of analyzing the environmental impact of products emerged, and initially LCA just focused on energy consumption and waste generation. It's interesting that in 1970s, the first company was the Coca-Cola company that used LCA for the packaging beverages. And they compared the different packaging, and they use LCA for the energy consumption and waste generation. And then the standardization of LCA is developed. In 1990s, the ISO developed standards guidelines for conducting LCA, ISO 14040. And we have another series that is newer, is ISO 14044. And then after that, in 2000s, and after that, LCA become more comprehensive with advancement in tools, databases, methodologies. And so what is the type of the LCA? What's the classification of LCA? We have two types of classification. The first one is traditional types of LCA, which includes attributional LCA. This type of LCA describes the environmental impact associated with the life cycle of the product as it currently exists. It's for the existing products. And this type of LCA used for product comparison and environmental declarations. And it helps us for understanding the impacts of existing systems. Another one is consequential LCA, which focus on analyzing the broader environmental consequences of changes in a system by considering market and behavioral responses. This type of LCA useful for policy analysis and decision making. As you see, here is an example that shows that how these two types of LCA answer two different questions. For example, ALCA answer this question that what part of the global environmental burdens should be assigned to the product, but consequential LCA answer to this question that what is the impact of the product on the global environmental burdens. We have a screening LCA, which provides a quick assessment to identify key impact area, and it's more useful for earlier stages of product development for guiding further detailed studies. We have simplified and streamlined LCA. The simplified LCA uses simplified models and assumptions to reduce the complexity and cost of the full LCA, and it's more useful for small businesses. But a streamlined LCA more concentrate on the most significant and important stages or component of the product or process for give us a quick insight for decision making. And it's more useful for big corporation and big companies. So we have another classification of LCA, which is more comprehensive, because this traditional type of LCA just focuses on the environmental impact, but the life cycle sustainability assessment, it focuses other than environmental impact, it focuses on life cycle cost and social life cycle assessment. So for the environmental impact, I mentioned in the previous slide, but the economic life cycle cost, it's more focused on the economic cost associated with the life cycle of a product, process or service. And it's useful when we want to calculate the cost benefits and economic feasibility, because more companies, they care about the environmental impact, but cost is actually very important. So we can use the life cycle cost. And social life cycle assessment analyzes the social impact throughout the life cycle of the product, process and processes. And it's important for understanding the social impacts and improving social sustainability. After that, we know that what is the type of the LCA. We want to know that what's the application of LCA. We can use LCA in different type of studies, but the most applicable one is that LCA can be used in manufacturing and product design, and it can help for reduce waste and improve sustainability. Can use in energy sector for identifying sustainable energy solution. It can use in construction and building design for developing and green building materials. It can use on automotive industry for supporting the low emission transportation. Can use on agriculture and food industry and waste management. So who uses LCA? Everybody can use LCA, but it's very useful for big corporations, governments and policymakers, researchers and academics, NGOs and consultants. So I mentioned that why we can use LCA, but more comprehensively, LCA can be is used because it can helps us to pinpoint the stages in a product life cycle with the highest environmental impact. It can improve sustainability. It can ensures compliances with environmental regulation and support certification efforts. It gives us a data-driven insight, so it can help for the decision making, and it can enhance the brand reputation. It can show a commitment to sustainability, which can improve the brand image and customer loyalty. Before that, we go to that how LCA works. I just need some interaction. There is a website. There is a really cool website. It's a cool California carbon footprint calculator. You can just scan this QR code, and this website, by this website, you can estimate your carbon footprint based on your energy use, transportation, waste, and shopping. So here I have the website. Here is the website, is my own calculation. As you've seen that you can start with where do you live, how many people are you, and you can have your how do you get around, the travel with the public transportation, vehicle, and airplane. And then it's the how much you use in your home, food, shopping, and then it shows you how many carbon footprint and how many tons CO2 equivalent per year that you're producing. It's a good estimation. You can just type your carbon footprint on the chat. But the reason that why we have this exercise for the carbon footprint is that there's a kind of make more sense how it's LCA works. Here you calculate your own footprint, but LCA is gonna expand that in the industry. LCA evaluate the environmental impact of the production from cradle to grave, from beginning up to end of life, with considering all stage of life cycle. With carbon footprint calculation, you see that how you can, there is some tips that how you can reduce your impact, and LCA similarly do this in an industry. It gives you that how you can reduce the environmental impact, cost, embodied impact, and energy use of your products. So if you're done with this, Andrea can continue with that, how LCA it works.
Thank you, Masa. So as Masa told you, there is standards for LCA, the ISO standards. The first one, the 14040, gives you the framework of the LCA, the phases, how interact with each other, the reporting, and the limitations. And the second one gives you the requirements to carry out with an LCA, and to comply with the first standard. So there are 4 phases that are interrelated with each other. The first one is goal and scope. So we need to ask ourselves 3 questions. Why are we doing the life cycle assessment? Is for product development, is for marketing, is for decisions for the public. So why is the reason? What is for? What is the intended application? And to whom? The results of the LCA will be made public to the audience, or will be only for the company for product development. So with these questions, we are going to define the functional unit, the system boundaries. We're going to define which type of impact categories we are interested in analyze, and how will be made the results public or not. So regarding the functional unit, So regarding the functional unit, it's very important to define this, especially for comparison and at the end, when we are interpreting the results, those results make sense. So for example, if we want to compare two methods to dry our hands, we can compare electric hair dryer, electric hand dryer with paper towel based on their weight. And if we do that, the paper towel will be more eco-friendly because it's lighter. But actually doesn't have nothing to do with the actual function of the hand dryer or the paper towel, that is to dry the hands. So a better functional unit will be 100 pair of dried hands. And regarding to that, we are going to define the reference flows. So the reference flows could be different and will be different, but not the functional unit. The functional unit is exactly the same. So we are comparing apples with apples. Now in this case, electric hand dryer with a paper towel. After that, we are going to define the scope. In terms of the scope, we have the system boundaries, and these give us what are going to be the stages of the life cycle of the product system that we are going to include or not in our study. So more generally, these are the processes that are included: the raw materials extraction and materials manufacturing, the manufacturing inside our facility, the operational or use phase, and the disposal or end of life. So these are more generally the processes that are included in a life cycle assessment. But depending on which stages are included, you will have different system boundaries. For example, gate to gate, when we are only focusing inside our facility, we will have the most common life cycle study is the cradle to gate, where we are including the upstream processes, the raw material extraction and materials manufacturing. And we will have the cradle to grave, when we are including also the operational phase and the end of life. And as Masa told you before, if we close the loop, and we recycle most of the materials back to the product system, we will have cradle to cradle. So depending on those, we will have different system boundaries. So how can we decide which processes we include or not depend on the results. And specifically in the standard, it says that the omissions of these processes can be done, but depends on the goal and scope, and actually it depends on the results. If the results are not significantly changed with the omission of these processes, we can delete them. So other processes are more context dependent, for example, transportation, and also the transportation of material, distribution. These processes may or may not be included. And for example, our processes are more excluded most of the time. For example, the diet of the workers or the commute they have to do to go to the company. So these processes are not included in environmental life cycle assessment. Yeah. For the second phase, that is the life cycle inventory, we could have aggregated process or disaggregated process or partially aggregated process. Depends on the facility or the study we are dealing with. So we will have inputs and outputs. Now, regarding the inputs and outputs, we could have elementary flows that are inputs and emissions that are going from nature and back to nature directly. And we will have intermediate flows that are products or waste that goes to another process, for example, recycling facility. So these are intermediate flows. And we will have to gather data for all of these type of flows, the most relevant for our study. So this is an example of a work I done in the past. This was for the environmental life cycle assessment of ammonia, but as an energy vector, in a combined heated power plant. So here we will have the processes that are in like blue, green, that is we have primary data for these processes, and we use secondary data for storage and transport. This secondary data came from life cycle inventory databases or the literature. And we consider in this assessment and intermediate flows. So we can see here that all intermediate flows comes from another process, no industrial process, or goes to another industrial process. Okay. So the third phase of the life cycle assessment is the life cycle impact assessment. So the first stage was to define what will be studied, which type of indicators or impact categories we are going to study for this product system. The second stage was gathering all the data to make the life cycle inventory. And the third stage is to actually calculate the impacts or estimate the impacts. So we have the inventory. In this case, we have all these emissions. And after that, we do classification. So for example, CFCs, the chlorofluorocarbons. These air emissions contribute to ozone layer depletion and also to global warming. So we, in this stage, the classification, or with the help with the software, we can classify all these emissions with the impact categories. After that, we do the characterization, because these emissions have a different contribution to different impact categories. For example, CO2 in terms of global warming is characterized as one, the potential is 1 kilogram of CO2. We see that for characterization on global warming, we can see that we have equivalent. But the CFC has a larger potential for global warming than CO2. So we do this characterization. The normalization, grouping, and integration are optional, in the standard to do. We can do it or not, but the first part, selection and classification and characterization, this is mandatory in a life cycle assessment. With that, we have two types of impact categories. We have the midpoint. We have the midpoint impact categories, and we have the endpoint impact category. When we have the endpoint, we have grouping and integration to have a single index about the environmental performance of my product system. Regarding characterization, for example, there is global warming. So in terms of mass, CO2 in this facility, in the chimney, has a larger mass, going out in the atmosphere. But in terms of global warming, in 100 years, actually the nitrous oxides will have more contribution. So this is especially important in the characterization part, but at least we have software to do this for us, to make those calculations. So the final stage is interpretation. We have numerical approaches, and we also have additional elements we have to do. In numerical approaches, we have comparative analysis that is very common. We have contribution analysis, best known for as hotspot analysis. We have a scenario analysis. We can do the best and worst case scenario. Sensitivity analysis, we change some of the parameters, and we see how much the results change. And uncertainty analysis, because for the life cycle inventory, is most common use average data, but we also have maybe a minimum and maximum. We use average data for the whole year. So we can do uncertainty analysis to be how much uncertainty in our results we will have if we change our values. So in the standard, we have to do a sensitivity analysis for our results, but this sensitivity analysis can be done with a scenario, a sensitivity, or uncertainty analysis. And we also identify the relevant findings, after we have the results during interpretation. We do data quality assessment, so we go back also for the life cycle inventory. We stay from the beginning, and also at the end, we do an analysis about the assumptions and limitations of our study and the conclusions and recommendations. So in terms of interpretation, it's very important to have clear what LCA does and what LCA does not. So LCA does not predict actually the impact, because there is a lot of the precise impact, of a product, or a system product. Because it's difficult to do that because of the relative expression of the potential impact, based on a functional unit. That is the whole thing about LCA. We also have you take a picture of a product system. So we have limitations in terms of geography or space and time. We have uncertainty in our data. And in fact, some of the potential impacts are future impacts. So there is uncertainty in the results, but nonetheless, because there are the limitations on LCA, LCA gives us direction of where we can go on the trends. So we can make at least fair comparison between the base case or the business as usual and an alternative. So yeah. So about future trends, machine learning, we can leverage. Machine learning in lifecycle assessment is very helpful for cleaning data, data acquisition, preparation. We can also fill some gaps in the data, or we can magnify the data to have more things to work on. We can do modeling with machine learning and optimization scenarios. So machine learning is very useful, has been very useful in these couple of years in LCA. And another trend regarding LCA is circular economy. Because circular economy is, well, how can we as society change from the linear economy, make, use, waste, to a circular economy, where all the materials, the usefulness of materials and the economic value of materials has a longer time. So in itself, circular economy is not sustainable, in terms of environment, social, and economics. So with a life cycle assessment, we can assess the sustainability of a circular economy strategy and avoid a burden shift. So that's important. So to finalize my part of the presentation, I want to mention as an example what is the work I worked. I have been worked in the previous and I'm working now. So this is from my previous work. I did with a collaboration with persons from the UK and in Ecuador, the environmental sustainability of ammonia for power generation. This is a different graph for the system boundaries. We consider the production, storage, transport, and utilization. And our goals were to compare the environmental performance of ammonia as an energy vector in different scales, and also compare the environmental performance as ammonia, in a combined heat and power plant, different technologies, and even in different locations. So the location for use was the UK, but we want to analyze what if we have an energy ammonia market. So if we can use ammonia from wind in the UK or in Morocco or Australia, what's the difference in the transportation, how much contributes to the total impact. We also use PV in Chile, hydro in Brazil, geothermal in Iceland, in nuclear in the United Arab Emirates. So we use different locations as well, depending also in the projects. There are facilities that are being constructed to produce hydrogen and ammonia for as energy vectors. So this is a summary of the results. We have different categories we analyze, and we can see that in terms of green ammonia, we can achieve a significant reduction in CO2 emissions, not only with green and pink ammonia, this nuclear, but for other impact categories, the transportation can have a very large contribution, especially for terrestrial acidification. And the second project is energy resilient in school. So the first picture is before and after Hurricane Irene struck Puerto Rico. But we can see here that several weeks later, a couple of weeks later, there is still a lot of parts of the island that doesn't have power yet. So because of schools are commonly shelters after a natural disaster, we want to enhance the resilience of these buildings. So the goal was to assess the benefits of building adapted PV on school buildings for community energy resilience and the associated environmental impacts and the cost of the transformation. So the functional unit for this case was 1 square meter of the total floor area of the school building along the lifetime of the PV panel, 25 years. And takes a little time. Well, we have, this is the system boundaries. We have as embodied impacts, the processes that the product extraction of materials, the construction of the building, and also the PV system, and the end of life. And the operational is only the use phase. So we have different scenarios. We have the business as usual, no PV. We have only PV. We have green energy, but not resilience. And we have the nanogrid with batteries. We also include we include a different scenario. What if we can use second life EV batteries instead of fresh batteries, and how the environmental impacts will change. And the microgrid, not only for the school building, but expand the system for the whole community, or the community around the building, the school building, or the residential houses. So we have the other results. We have the contribution for the nanogrid scenario, and we can see here that the embodied impacts for ionizing radiation and mineral resource scarcity are larger, and the operational phase is larger for global warming, freshwater eutrophication, and other impacts as ozone layer depletion as well. So we could see the difference, and we can see that there is always trade-offs. There is not a perfect solution. There is always trade-offs, and LCA help us to identify those and try to minimize these. So back to Masa. Thank you.
So can you hear me? So another project example for the application of LCA. This is my first project in PhD that we use parametric LCA for designing resilient building in Miami, Florida. So the case study was the Miami, because the houses, especially residential houses, has a high energy consumption, and they are a hurricane prone area, and there is lots of socioeconomic diversity. So we picked this location, and for the residential houses, we wanted to see we wanted to compare the energy use, greenhouse gas emission, and life cycle costs of designing a resilient house compared to conventional and average house. So here this picture shows the graphical abstract that what we did. As you've seen that we used LCA for comparing conventional house and resilient house, and we considered the cradle to grave study. And here is the results that here is the result that we used LCA for obtaining these results. The system boundary of my study is that it's from production up to end of life, and the stages in blue shows the pre-use phase, and the red one shows the use phase, and the green one shows the end of life phase. As you've seen that the white boxes is the one that I didn't consider in my study, and the impact, the outputs that we had here was the initial embodied impact, operational energy use, and end of life embodied impact, as well as associate costs, such as initial costs, operational and replacement costs, and total life cycle costs. This shows the framework that how I did this study. As you've seen, we had data and features for the conventional houses and resilient houses. We use building geometry, system parameter, occupants, Miami climate data, and energy cost data. I use the BIA tool, which is the parametric life cycle assessment tool, and I adapted for the resilient building. This tool use energy model, material model, and cost model, and gives us two outputs. The first one is the global warming impact, and the second and life cycle cost, and the other output is that using the LCA results for giving us the different design ideas with combination of different attributes. And then from this output, I compared the life cycle impacts and cost of the resilient houses and conventional houses. And from these, I prioritize the resilient attribute and sustainable attributes. At the end, I did the sensitivity analysis for the calibrating the model. And at the end, we had some designing feature and designing and resilient and sustainable and cost-effective building at earlier stages in the design phase. Here is the results. In the results, as you've seen that in embodied energy, resilient buildings shows the small increase in embodied greenhouse gas emission compared to conventional. It's around 0.1%. But in the replacement, because we are using more durable and more sustainable material for the resilient buildings, there is a 12% reduction in greenhouse gas emissions compared to conventional buildings in just replacement stage. And for the operational energy, as we expected, resilient houses shows around 1% lower operational energy emissions, and the total greenhouse gas emissions shows that we have the efficiency in resilient houses, and it shows we have a reduction of total GH emission in resilient houses. The results of life cycle cost shows that the total embodied energy cost for resilient houses is around 4% higher, but in the operational energy cost and total cost, they show that they are more cost friendly, the resilient houses compared to conventional. As you've seen that they have the lower operational energy and total cost. This figure shows the second output. As I mentioned, we use the LCA results to prioritize and ranking the building design attributes. And here shows the most important attributes in resiliency design and most important attributes in building sustainability design. From this project, we understand that at the first, resilient houses has a bit more cost and energy use, but in the long run, they are cheaper and they are most environmental friendly. And within this model, our next step is expand the model to other climate zones and other type of building, like commercial buildings in US. And here LCA shows that how help us for making decision in the earliest stages over the building life cycle. The second project that it's an ongoing project that I'm doing it right now. It's on the earliest stages. There is a project that it's a collaboration between Lowell and these universities and national labs, and HEAT, which is the HEAT. It's an NGO. It's an NGOs that I'm working as an intern here. That they are developing a network geothermal system for residential and commercial houses in two case studies, Framingham and Lowell. But there is still no LCA studies that to shows that how it's gonna be environmentally beneficial and cost beneficial. So I'm doing the LCA. I'm using the LCA for the geothermal vs HVAC systems in Lowell to show that how this network geothermal can be go near to zero emissions and replace gas. So here shows the network geothermal design. As you see, the location and the buildings that we are going to install the network geothermal, and also it's a ground source heat pump. There is a 3 commercial buildings and 8 residential buildings that these network geothermal gonna connect to those. The goal of this study is analyze and compare the environmental and cost, life cycle cost of ground source heat pump and commercial HVAC systems. The scope is gonna be entire life cycle from manufacturing up to end of life and disposal. And the functional unit, it's gonna be total thermal energy delivered kilowatt hours by the ground source heat pump and HVAC system over their expected operational lifetime. Here is the system boundary that shows all the inputs, the life cycle phases, and the outputs. And we are at the end, we are gonna have a results for life cycle impact and cost assessments. The other study that I did for the resilient buildings, we just considered global warming potential and energy use. But in this study, we are going to analyze the other impact categories as well, such as air pollution, because it's really important because the geothermal gonna use the groundwater. So it's really important to see that what's the impact on air, on water pollution. And we are going to have a life cycle cost analysis from initial cost up to disposal cost. And the expected outcome, as in the other study shows and other reports, it would be that ground source heat pump significantly reduce operational greenhouse gas emissions and energy use. And it may be different from in the different location and climate zones, but generally, despite that they would have the higher initial cost, but they are more beneficial in the long term and have a lower long-term operational cost. So with all of these examples and the things that and the stages that we talked about, the LCA and the definition and everything, we can say that why LCA matters for energy. LCA shows the total environmental impact of energy system from creation and production up to disposal. So it helps us to make an informed decision about using energy. That's the way that they are more environmental friendly. It can boost renewable energy by evaluating things like solar panels or geothermal systems. and can ensure us that how this technology are beneficial for the environment. It gives an insight for creating policies that promote clean and efficient energy use. And LCA will continue to be a key tool. As we've seen nowadays, it's uses in all the research areas, fields, and companies and corporations. They are effective and helps us to have a more sustainable energy solutions. And the LCA help us to build a future where both people and planet can thrive. And the last slide is that the comprehensive tools for LCA, there is lots of databases, software tools. Some of them it's not free, some of them is open sources, online platform and tools, and there is the guidance and standards. Thank you for your attention.
Thank you both so much. This was incredibly helpful for me personally, and I imagine so for our audience as well. Definitely interested in the projects that you're working on, and I loved how you gave us a really good baseline understanding of what we were looking at in the LCA landscape, because I think, you know, it is a lot bigger than I even imagined as well. I knew it was very comprehensive, but it's nice to know that there's different steps, and I thought your visuals were great for breaking down how you have to look at this truthfully. So we did have one question come in about the social impacts that are included in your studies, and I see that Andrea already answered that, and I'll just read it for folks. Some of those would include health and safety, fair salary for workers, food security, and community engagement. So that's incredibly helpful to have for context. And we did actually also have some questions come in during the registration process. So I'll start there, but if anyone else has questions, you can feel free to drop that into the chat and we'll make sure to address them. So one of the questions that came in during registration was, what are some takeaways of using LCAs for batteries and EVs, and how can we use that information to break down barriers for EV adoption? I think you have some context for that in your presentation as well, so if you just wanted to summarize quickly.
Yeah,
I can...
well,
okay. Well, you can go.
Well, I can, and Masa can complement. Well, for life cycle and EV batteries is a new field, no? And the problem in the future is what we are going to do with the at the end of life of the battery, because in a car and an EV car, when they lose 80% or less than their capacity, the storage capacity, they are replaced. So in the future, we will have a lot of batteries that are still useful, but some of the alternatives is to have these EV batteries that are still working for stationary applications. That is why we were considering this scenario for the project I present, using second life batteries for storage in buildings. So that will be one way to do that. And also in the batteries, the production of the batteries has a lot of embodied impact. So with using different alternatives, we use an screen LCA or a comprehensive LCA to see what type of materials can improve the environmental profile of the EV batteries. I don't know if Masa has something to...
I can just add that the very good point of LCA is that it gives you that all the questions in the scientific, for example, EV batteries or conventional vehicles. We don't have 100% right or wrong. There is no black and white. Everything in LCA is in the gray shade. So it shows, for example, for the EV batteries, in a short term, they are gonna have some beneficial, they are environmental friendly, they reduce carbon footprint, but the recycling, it's a big problem. So we cannot just say that EV vehicles are very better than the gasoline one or reverse. The good point of LCA, we can have the separate comparison in each life cycle stage to show and it depends on the goal. The goal is what is that? It's just for example, it's a cost, it's just environmental, it's reducing carbon footprint in a short term, or it's for a long term. So the good point of it is that it gives us a comprehensive insight to not have a visual of black and white for everything.
Yeah, I loved the point Andrea made about there's no perfect answer, and that's exactly what you're reinforcing here. Turns out Newton's third law is really a big deal. Every action has a consequence, right? So LCAs can be an excellent tool for that. So the next question that we had been asked, since I'm not seeing any additional ones in the chat, was how do LCAs support Scope 3 footprinting for companies in a lot of their emissions reporting that companies are doing? Of course, the Scope 3 emissions are from those assets not directly controlled. So are you able to speak to that at all for LCA's involvement?
I can add that Scope 3, it's indirect emissions from companies' value chain, including the purchase goods, business, travel, and product use. But for LCA can tracks the environmental impact for the all stages of products life cycle. And it can gives off a detailed data for that indirect emissions as well. So we can easily use that because we have a detailed data on the indirect emission, and this help industry to understand, for example, that stage and reduce the full environmental footprint. So it's not just applicable for the scope 1 and 2 emissions. I think we can, as these are the other studies that they use life cycle assessment for the indirect emissions of the, especially the big industries as well.
Yeah, so clearly it plays a big role in emissions reporting, regardless, it sounds like, of which scope you're looking at. Awesome. And then just as we wrap up here, again, if you have any questions, I have a few minutes, I can stick around. Hopefully our presenters can too. But the last one that I was personally curious about was how do you find balance with the comprehensive nature of LCAs and even just in your personal life needing to make a short-term decision, perhaps, I still have an old gas furnace. I'd love to get rid of it. I got some work I would have to do that in my house, upgrading electrical and whatnot, which has its own impacts. And I have to admit, I'm fully in analysis paralysis because, for instance, a good half of our grid emissions in New England actually come from natural gas being burned or fossil fuel being burned somewhere else, just not in my house. So how do you look at balancing that sort of complex decision making that should be simple in theory?
Actually, it's really interesting question. The one answer could be, as you remember, I mentioned different type of traditional LCA. One of them was a streamlined LCA. So this is the very can be useful for your question because a streamlined LCA, it's a simplified LCA, just focus on the most important stages at the beginning. For example, if you if your company want just quickly reduce the environmental impact of packaging, product packaging, and you don't have that much time, so you can use a streamlined LCA and just estimate the environmental impact by just focusing, because the comprehensive LCA takes time and money and resources. And after that, you can complete your LCA study during the time up to, because that is the flexibility of LCA. It's a good point of that. So at the beginning, we are using the streamlined LCA because we don't have money or resources. And then after that, during the production life cycle, or even after that, we can continue and complete this study. So it's not necessary we need to have a comprehensive LCA before the producing a product or something.
Yeah,
I think that's gonna be one answer.
Yeah, and I just want to add that it's very useful to have LCA or life cycle thinking at the beginning, on the early stage of product development. And we have to we have to accept the idea that will be a lot of uncertainty. So we have more freedom, to change things, but the uncertainty of the results of the LCA will be higher. So we have to accept that and actually have the LCA to guide us, not actually rely on the numerical results, but guide us in which type of decisions we can make.
Awesome. I really appreciate that. Yeah, I wasn't aware of how many different types of LCAs there are and how you can draw the box in different areas in order to limit the scope of your initial study and then realize from there where you go beyond that. So I think this is an excellent presentation. I'm so thankful you both gave us your time today and time to prep this. We really appreciate it, and we thank all of our attendees, and we will be able to send out a recording of this to everyone in case they missed it. And I believe we'll also be able to attach the slides as a PDF too. So please feel free to share with your friends if they have any questions on LCAs, and big thank you to our presenters.
Thank you. Thank you for the
Thank you so
opportunity.
much.
All right. Have a
Thank you
lovely
for giving
afternoon.
us this opportunity. You too. Thank you
Thank you so much. Yeah. Bye, everyone.
Bye.
Bye.
Thank you.
Oops.
Yeah.
Hey,
Yeah.
I'll just stop the recording here.